再努力一场就可以休息了。Okay, let's start the third session of the day. Okay, the opponent please propose one problem.
Problem number 14, water bottle rockets.
14. Okay, good.
pressure will build up inside. When the bottle is released, the water will spill up at a high speed. So it creates a thrust that can push the bottle in opposite direction. Next is conservation of momentum. Momentum is a product of mass and velocity. So according to the law of conservation of momentum, its total momentum of before the event will equal to the total momentum after the event. So if I define our system is the rocket plus fuel, it will be a closed system. So momentum inside is conserved in this system. And momentum in the one direction will give the water bottle rocket exhaust gases, but if the another direction is given to the rocket itself. So I also calculate the momentum in my experience. Here is its result. Next is the acceleration changes during the lift-off. According to the theory I mentioned above, I can calculate a formula for the acceleration. IC is related to the mass, the thrust, and drag force and gravity force. And this is my experience acceleration analyzed. It is 100 milliliters. And I found that the acceleration must be the same always. At early stage, the mass is big because it's full of water. So the acceleration is high. But at the mid stage, its water has been all ejected out. So the mass will reduce very much, but its thrust will remain the same. And it will have the highest acceleration. At the next stage, there is no water, so it has the smallest mass. Its thrust becomes smaller, but its air resistance and gravity become bigger, so its acceleration decreases. According to my experience results, I saw that the water temperature play a role. When I increase the temperature, it will increase its pressure, so it will have the stronger thrust, makes its acceleration bigger. Also, when I increase the temperature, I will reduce its viscosity, so the water will eject it out easily, so it has a bigger acceleration. Here is our parameters. The amount of the water and the temperature of the water. Now is conclusion. In summary, high water temperature will impact the acceleration, but not much, just a little. And during the lift-off, acceleration will increase at first and reach its peak, then decrease due to the water loss or the thrust and drag force others. Next, in my experience, I saw that the less water I use, it will get a larger acceleration. For example, in my 100 milliliters, I get a larger acceleration at 8.307. Thank you for listening to my presentation.
What is your definition of lift-off?
Lift-off, when it's hold the water bottle release and
the whole process?
Yes.
Okay. And do you consider that because you use the water volume to be your manipulative variable, right?
Yes.
So do you think that there will be a critical value that the acceleration will not greatly increase?
Yes.
Okay. And your flying trajectory is the vertical direction, or will have the degree?
What type of maybe we will consider that in the future later children.
So do you think that a different degree of your flying trajectory will affect the center of mass of the water bottle? The center of the
I think what is the center?
the center. Okay, let's compare. Have you considered the rats during the experiment?
Yes.
Okay. Do you think that? Sorry. So do you think that which time will the acceleration meet to hit the highest point?
When the water is all ejected out, it will have the biggest acceleration.
Okay. Do you think that because you change your water bottom, do you think the chance that the center of mass will affect is accelerated about your data?
Okay, second.
Do you think that the center of the mass, because your trajectory is not vertical,
Yes.
so the center of the mass will change, and do you think that will cause a stable and they will affect your data?
Yes.
Sorry, the time is up.
and today I'm going to oppose the problem number 14, water bottle wrapping. And here is the problem statement above, and my main focuses are how do the relevant parameter affect the acceleration and the flight trajectory, and how do the air pressure and water volume change during the launch process. And here's the review of the report. During the presentation about the theoretical model, she used the Jack equation and the ideal gas law and the conversion of the momentum. But I I think that there is a lack of the force analysis about the propulsion process and didn't analyze the third because I think the thrust will affect the acceleration, so I think that's important. And about the experience data, she used the temperature and the different water volume to be her manipulate variable. And I think she did great that she made sure the acceleration about measurement during the launch process. But I think that she didn't consider the difference of the air resistance in each situation and didn't consider the shift in the center of mass and didn't connect the data with the theory. And about the data analysis, she calculated the acceleration force of the water rocket and she considered the air resistance. I think that is important. But she didn't consider different water eject velocity because she said that the trajectory is not vertical. And I think that degree will affect the water ejection velocity and it will also affect the acceleration. And she didn't connect the data with the theory. And about the discussion point, during the presentation, I want to discuss the conservation of the momentum and energy and the check between the interval pressure and the water volume in the water rocket. I want to ask that with the air resistance which affect the acceleration change and how that is affected. And about the experiment and setup, I want to discuss the stability control of the device because she said she used the about the trajectory is not vertical. And about the measurement of the water ejection velocity and the acceleration measurement during the launch process. I want to ask that do you consider the impact of the weight when altering the water volume because when you increase the water volume, the energy of the water volume will also increase and it will affect the acceleration. And did you consider water ejection velocity and the shift in the center of mass at the different sound angle? And how do you calculate the change of the air pressure? And about the data analysis, I want to discuss the effect of the water volume and the launch and the acceleration and trajectory. And I also want to discuss the variation of the internal pressure with time and volume inside the bottle. I think that is my focus. And when I want to the discussing point, I want to discuss with you is when the changing water volume, the weight will also change, and how will that affect your experience data? And under what condition will the acceleration reach its maximum value? Because you use the water volume to be your manipulator variable, and I think that will have the critical value. And that's all my presentation. Thank you. And I want to invite the reporter. Can you turn to your page 17? And you use the ideal gas flow to be your manipulator variable. So how can this formula connect with your data?
So I use temperature. It's related to pressure of that one bottle.
Okay, so can we use this? I think that the ideal gas flow is equal to PV equal to right.
Yes.
But if so how did you fix your pressure? All your experiment and fix your whole situation in your experiment? No. Oh, why? Yeah, because I think that when you use the water volume to be your manipulator variable, you will decrease the bottle between the air volume, right? So it will decrease. So and I also want to discuss with you that because you consider the air resistance.
Yes.
Right. And do you think that air resistance will? Can you show me your air resistance data? In page resistance and about your drug. What do you mean that the drug equation is which drug? What did your FD means?
FD is when the water bottle fly out, and it will have a drug force and air resistance.
Okay. I also see that the formula in this, but I think that I'm very confused that why your data will be this trend. Can you explain this?
Because the it will have
Yes, because that I think that the velocity of the water bottle rocket will increase, right, during the process.
Yeah.
So in your formula, it will. I think that the air resistance formula will equal to this. It will equal to the velocity, right? When your velocity bigger and your air resistance will be bigger.
Yes.
And you said that your jet force is about your air resistance. So why there will be this trend that it will increase?
because when a water bottle is released, its velocity will increase.
Yes.
Because it flies very high.
So why the jet force will decrease?
Because the velocity decreases.
But you say that the velocity will during your experiment process will increase, right?
I say my velocity will decrease.
But I think that your data. Can you turn to the acceleration data? But because that your thank you. In your data, I cannot see that your velocity will decrease because your is bigger than 0. Okay. And I also want to ask that because you have water volume to be your manipulated variable. So do you think that there will be a critical value back because that the water volume will also affect the mass of the water, right?
Yes.
And it will have the force that turn down, right?
Yes.
So do you think that the acceleration will keep the mass that it will not gradually increase? Do you think that there will be the there will be the critical value that when you increase your water value and your acceleration will not gradually increase?
Yes, that is a critical point.
Okay, and I think that in your data, this is not the. Can you explain the trend of this data? Why this data is not the instant stable, not the acceleration?
Because when a water bottle is closed down, it maybe has a drag force or something force that influence it.
Yes.
So its velocity will have something change.
Yes. And in the short question time, I asked you that what is your definition of critical? And you said that is the whole of you is the whole process of the launch process, right? Yes. And so I also want to ask that there will be the thrust to make the water bottle rocket front. And it will be, I think I can divide it into two parts. And the first part is the water that will push the water bottle rocket like flying. And there will be the second part is that all your water is outside the bottle, and there will be still the air pressure. Yes. And do you think that they will maybe because that the acceleration is not stable?
Yes, I think. Yes, I agree that.
Yes. Okay. And can you turn to page 9? Yes, because I think that in this two picture that the different degree will affect your data, because I think that when you use different degree to launch the water bubble rocket, and the center of the mass will be different, and that will affect the ejection rate.
So yeah, I didn't consider the degree test when I'm doing the next experiment, but maybe I will consider that in the future.
Okay, and I also want to.
Because there are the same angle at the first when they release it.
Yes, but what I mean is that about the different experiment is that did you fix the did you stick the launch angle in the first time in the initial?
Yes.
So what is the degree?
I didn't put it.
So how do you measure your degree?
I use tracker.
Okay. And I want you also like that. What is the? Can you turn to the page data that you show the maximum of the acceleration?
This one.
So I think that is the page 32. Yes. Why do you think that the acceleration of the 100 will be the largest?
Because in my experience, I use these three validators, and in my analyzed results, I get lower.
So yes. Yes. So do you fix the pumping times?
Yes.
And you fix each pumping time. But I think that so you fix your pumping times. You fix the air volume that you put into the water bottle rocket.
I promised it until the water bottle rocket released.
So do you think that air volume you put into the bottle is fixed? Or is different? But as if it's different, it will also affect the acceleration, because that will cause the different turns, right?
Yes.
Yes. So I think that is main is the reason that your data is not stable, and I didn't see the trend of it. And that's all my question. And during the discussion time, we talked about her theory about the ideal gas, and I think that because she used the water volume to be her manipulator variable, and it will affect the mass of the whole of the water bottle rocket. But she didn't explain that what is these two will have a data. She didn't connect her data with her theory, and I think that because I think there will be the reason why her data she cannot show the data change, because she didn't fix the air volume she put into the water bottle rocket, and they will affect the thrust about this experiment, and it will affect the acceleration. So I didn't think that is accurate, and I think that the launch degree will also affect this experiment, because they will affect the center of the mass. Thank you.
Thank you. Question from the reviewer.
Okay, so first I have a question for the reporter. Can you please turn to the page where you mentioned the momentum of the rocket and fuel? You should go back to the page where you drew a diagram, and you said that did you consider the air pressure difference, which causes a thrust when the water is ejected?
Yes.
But in your theory, I didn't see the formula that calculated the value of the thrust.
Can't say again.
I mean, do you think that the water, the air pressure is equal to the pressure of the environment when all of the water is ejected? Or does the air actually accelerate the rocket after all the water is ejected?
Yeah, I didn't consider that.
Okay, so do you think that, okay, so now I will ask the opponent, do you think the pressure difference will cause a second phase of acceleration when the water is ejected?
Yes. Yes, because I think the air pressure inside the balloon will affect the thrust and it will accelerate acceleration.
Okay, did you correct, okay, so I have questions for the reporter. Did you correct the error when you use the ideal gas law? Because the realistic state of air doesn't match the ideal gas law. Did you correct your data?
I have reached the area.
So this is just one of your assumptions in your theory model,
Yes.
which isn't the realistic state of air in practical experiment, right? Do you agree with me?
I have used it in my experiment, but I didn't measure the result.
Okay, so last, do you have a theoretical line? Do you have a theoretical data in our diagram?
No.
Okay, this is all my questions. Thank you. Okay, so greetings to honorable judges and fellow contestants. This is the reviewer from Minglao High School, and today I will be reviewing problem number 14, water bottle rocket. So to reaffirm the reporter's main focus, the report is mainly discussing about the effect of temperature of water, the water volume, and the change in acceleration during liftoff. And in their phenomenon, they observed the acceleration process of the rocket, and in their theory, they consider drag force, the ideal gas law, Newton's third law, and the conservation of momentum. And in their experiment, they're changing the water temperature and the water volume. In their conclusion, they stated that the temperature only has a minor effect on the acceleration of the rocket. And this is the review of the reporter. She has a comprehensible comparison between the theory experiments, but minimal graphical elaboration. And for the opponent, the questions are all sharp and well structured, and there are alternative approaches when in the discussion session, and there's strong error analysis critique. But overall, the over-reliance on personal opinions and time mismanagement on discussing are the main cons of the opposition. And in their key discussion, they mentioned about the ideal gas law relation to the data, which the opponent asks, according to the ideal gas law, how is the air volume controlled, which the reporter doesn't take into consideration. And our point of view is by changing the temperature, the amount of air particles is changing, so the temperature is actually not directly correlated with the pressure. They also talked about the air drag formula, which is the release angle control, which the reporter denies, but I think the release angle may affect the acceleration value of the rocket. And the opponent also asked why 100 milliliters will have the largest acceleration, which the answer is the mass is low, but I don't think the water mass is directly correlated with the acceleration value. And for our questions, I asked that if there is a second phase of acceleration, which the opponent agrees with me, but the reporter didn't answer. Also, I asked if the error is corrected between the theory and realistic state, which the reporter says no. And at last, I want to talk about the points they missed. In the theory session, I think that they didn't consider the energy loss when the air in the bottle expands, and the pressure difference which creates a force when there is no water ejected. Also, in the parameters, I think that nozzle efficiency is also one of the key parameters that they should consider, and they didn't quantify air pressure, they're only changing the water temperature. And I think that no comparison between theoretical and experimental data, and no boundary limitations, such as successful launch, are the key flaws to their data analysis. This is the end of my review. Thank you.
Okay, so you should please give your conclusion.
In the experiment, we used a standard. Wait. In this experience, I want to try something. I said we use the same value when we change the temperature. Maybe I said wrong in the past. Okay, and when we use and the value we use 200 milliliter instead of bulk. And when the angle that problems, I said wrong. I use something to fix the angle. Yes. And the value and the PV equal to nRT is V won't change a lot because it's long. So I didn't calculate a lot. And it's the thing I use to fix the law is this, like this. Yes, it's just like this. Okay. So if I don't move less, it won't change. So its angle will be the same. Yes. Okay.
Okay,
think that the acceleration is not gradually decreased is because that they will, the first can divide it into two parts. First is by the water, and the next is that the water all turns out. There will be the air pressure that push the water bottle rocket, and I think that is because of the difference.
I don't think that it is an oscillation or something. It's because in tracker, how it calculates the acceleration is by differentiating the VT diagram. So when you track the VT diagram, it's not a smooth line. So when other differentiation that causes the graph to look like it has oscillation.
And I also think that the air resistance will also affect the acceleration because it will, because the V is not the same. So when the V increase, the air resistance will also increase, and that V will affect the acceleration on the channel per theta.
So you can see the up and down is just an artifact from your data analysis too.
So pardon me.
You just tell me the up and down is not physical, it's by your
Yeah, I think it's calculating error from tracker. Yes.
okay. Good. Thank you.
Any more questions?
I saw you were using the idea of gas 4 years ago to govern the change of pressure and volumes. But did you notice that that law is to be equal thermal condition, meaning that you change the pressure and volume really slow. Keep a constant temperature for your experiment to be valid. But during a launch or water launch rocket, I think the expansion is quite fast. So does that formula still apply? Or maybe you should change into another formula like the adiabatic expansion.
Actually change to another formula.
I mean, that's something for you to think of, and something for the opponent and reviewer to think about.
I think that cannot fix her experiment because that this formula is for the gas, and you just change the manipulator variable is your water temperature, so it cannot fix.
I think the diabatic expansion actually corrects the error in our theory because the injection process is very fast, so the whole air expansion can be seen as a diabatic expansion. So I think that it is a correct correction. I think that it is a valid correction.
I think that her data is real because that she increased the temperature of the water, and it will also cause a little energy lag will increase the air temperature, but I don't think that it will change that much.
Okay. Thank you very much.
Let's take the scores. First, the scores for the reporter are 6, 5, 6, 4, 6. Next, the scores for the opponent are 7, 7, 9, 8, 7. Finally, the scores of the reviewer are 7, 6, 8, 6, 8. Okay, great. Then that concludes today's debate. I wish all of you have some good time. Thank you very much.